Okay, today we will discuss about stacks in data structures. In the last session, we saw what is data structure, what is data, and what are different types of data structures like linear data structure and non-linear data structures. So, stack is one among them, where a stack is a linear data structure which follow the principle of last in first out. That means here the element which has been inserted last will be removed first. That means it will be popped out from the stack first, and the element which has been inserted first will be taken out at the last. So here, mm, in the stack, all the operations, that is whether it may be inserting or whether it may be deleting or whatever the operation may be, that operation, all operations will take from only one end, which is called the top. Here the basic operations are the push, pop and peek, and is empty and is full. Then what is push operation? Push operation is nothing but an inserting element into the stack. So here, when we use the push operation, and when we provide a when we provide an element to push an element into the stack, this push operation will push an element into the stack. Then there is another operation called as pop. This pop operation will remove an element from the stack, but how it will remove basically is, it will not remove an element that we are going to specify. It will remove an element which is at the top of the stack. And then is peek or top. This peek operation will be used to view the element which is at the top of the stack. So for that purpose, the peek operation will be used. Then there is another operation called is empty operation. This is empty operation will be used to check whether the stack is empty or not. And there is another operation that we use in stack, is full operation. This is full operation is used to check whether the stack is full or not. Like this, these are the many different operations that we use in the stack. Now we will see the push operation in the stack. So if you see this here, it is first the stack will be empty and the top will be pointing to the -1. Uh, when I push an element into the stack, that is the element here is A, and I will give as input to the push operation. So when I give this element A to the push operation, the push operation will push that element into the stack. Then the element will go below the stack and it will get stored there. Then the top will get incremented from -1 to 0. That means here the top will point to the 0th position. Now we will see this. If you see this here, now I will give another element, that is B, to the push operation. Then the push operation push that B element into the stack, which will get stored above the element A, and then the top will be incremented from 0 to 1. Then I will push an element, that is C. Then it will get stored above the element B, and the top will get incremented to 2 from 1. Next I push the element, that is D. Then D will get stored above the C element in the stack. So here, since the stack size is that is 4, so here, and since it is 4 and I have entered already 4 elements, then the stack is full right now. So that means if I try to push any other element further into the stack will not able to take that element and it will give a message, a stack overflow. So this is how we'll push an element into the stack. So now we will see the definition of the push. Here push means adding a new element to the top of the stack. The algorithm to mm, the algorithm for this push operation is like this. Here we use array. Using array we will push an element into the stack. Here initially if top is equals to maximum minus 1. Here maximum minus 1 we will take here basically because the stack index start with 0, and as we see in the previous slide the stack size is 4 and it will start from 0, so 0 to 3 it will point, so max value will 4, so it will become 4 minus 1, that is 3. So if top is equals to 3 then it will print stack overflow. Otherwise, that means there is a space in the stack, that is the meaning. So it will go to the else part and it will first increment the top from by 1. So top in the new top will become top plus 1. So at that new top, the item that we want to insert will be stored, that is stack of top is equals to item means here what? The new item that we are going to push, that will get at the new top, this top, new top of the stack, and here the if statement will end. So this is the array implementation of push operation in the stack. And now we will see the C program for push operation. So first we will write hash include stdio.h and we will define the maximum size of stack as 5. That means maximum we are going to store 5 elements in the stack. Now int stack of max. So this stack stack is of the size max. The max value is 5. So the stack is going to store maximum of 5 element, and since it is implemented by using an array, so we will write the statement like this: stack bracket inside max and like this, close it. Now initially top will be equals to -1, then we'll go for the push operation. So void push int item is the element that we are going to insert into the stack. Then if top is equals to maximum -1 means that indicates the stack is full, so it will print stack overflow. Else if top is not equals to maximum -1 means it indicates that still there is space in the stack. So that is why top will be incremented by 1. So the new top is equals to top plus 1. So in that new top I am going to insert this item. So stack of top is equals to the item. So that item will be printed like this. So printf %d pushed into the stack, that is item. That means any value that we have pushed into the stack, it will print that element pushed into the stack message. So this is how we are going to push an element into the stack. After that, if you want to see that element, then we can use the display operation here. So we will write void display. If top is equals to -1 means there are no elements in the stack, so it will print stack is empty. Otherwise, that means there are some elements in the stacks. That is why the control goes to the else part and it will print stack elements are. So like this, and since it has to print the elements from the top, that is why initially we will take I is equals to top, and this I should be greater than or equals to 0 and it will keep on incrementing. because we want to from 4 to 3, from 3 to 2, 3 to 1, 3 to 2 and 2 to 1, we will go like this to print. So that is why it will decrement here. Then it will print a percentage slash and stack of I. So here I is what? Top. It will become stack of top. So the element which is at the top of the stack will be printed first. Then I will decrement and that will become the new top. Again it will come here stack of I. Then it will print the next element which is at that position. So like this all the elements in the stack will get printed. This is the main we are going to write it here. So we are going to push 10, then push 20, push 30 and display. So whenever this push 10 executes, the control goes to the push operation and it will push 10 into the stack. Then it will push 20 into the stack, it will push 30 into the stack, then display will occur. Display operation executes, and once the display operation executes, since the last element we pushed is 30, 30 will be printed first, next 20 will be printed, and next 10 will be printed. So this is how the push operation and the display operation will execute. Here the applications of stack. So here applications of full operation. It will be used to call the functions or a recursion. Recursion operation will be in recursion operation. It will be used. It will be also used to evaluate the expressions like infix, postfix, and prefix operations. And it is also used to undo and redo operations in text editors where we enter the data and then we will do redo and undo operations. Then it is also used to navigate through the browser history. So these are some of the operations of the push.